Hello everyone, welcome to our channel Lessons of Life. In this video, we are going to discuss the problems of Codeforces round 790 division 4. We will discuss 5 problems A, B, C, D and E, and we will devote even amount of time to each and every problem because one particular problem may be easy for some people but it may be of slightly higher level for others. We have also added timestamps, so if you want to specifically see the solution to a particular problem, then you can use them and reach to that particular problem. Okay, so before beginning, please like the video, and if you are new, please subscribe to my channel. Yes, I know that you will not subscribe, but it is my duty to say to you to subscribe my channel. So please subscribe the channel and also recommend this video to your friends if they were stuck in either of the 4 or 5 problems that we have discussed in this video. So let us start. Okay, so let us take problem A. Problem A is pretty simple. I hope most of you solved it easily, but for the sake of completion, we will discuss it as well. The problem statement goes as follows. A ticket is a string consisting of 6 digits. A ticket is considered lucky if the sum of the first 3 digits is equal to the sum of the last 3 digits. Given a ticket, output if it is lucky or not. Okay, so the input will consist of the first line, the test cases. The description of each test case consists of one line containing one string consisting of 6 digits. So we have to output whether the string is lucky or not. So in this question is stated in the problem statement, we only need to check if the sum of the first 3 digits is equal to the last 3 digits or not. The digits in the string are given in the form of characters. So if you want to find the numerical value for that character, you can find it by s of I minus 0. So the only condition we need to check is if s of 0 minus 0 plus s of 1 minus 0 plus s of 2 minus 0 is equal to s of 3 minus 0, s of 4 minus 0 plus s of 5 minus 0. Okay, so we can see the code for it. So here is the code for it. First I have taken the input for the test cases, then I have taken the string s as an input, then I have done nothing more than what we have discussed in the solution. I have checked if the first 3 digits are equal, their sum is equal to the sum of the last 3 digits. Okay, so this is the code. Thank you. Okay, so now let's move to problem B. Problem B is also easy. The statement goes as follows. There are n boxes with different quantities of candies in each of them. The ith box has ai candies inside. You also have n friends that you want to give the candies to. So you decided to give each friend a box of candies. But you don't want any friend to get upset, so you decided to eat some candies from each box so that all boxes have the same quantity of candies in them. Note that you may eat a different number of candies from different boxes and you cannot add candies to any of the boxes. So we have to find the minimum total number of candies that we have to eat to satisfy the requirement. The first line of each test case contains a single integer n, number of boxes, and the second line will have the number of candies in each box. Okay, so if we discuss the solution to this video, to this problem, so according to the statement, it is clear that we want to make the number of chocolates to be equal in every box, but we cannot increase the chocolates, we can only decrease them. So it is obvious that we will have to reduce the chocolates in every box to the minimum chocolates present in any box. For example, if the height of these towers represent the number of chocolates, then we can clearly visualize then we need to cut all the towers to the height of the smallest tower to make them equal. That means that we will need to cut all the other tower to this height. And similar is the case with our problem that we will need to reduce the number of chocolates in every other box to the minimum number of chocolates present in any box. Okay, so we need to add to our answer a of I minus minimum chocolates to answer. So we can see the code for this problem. So if we see the code, first I have taken the input for the test cases. Then I have taken the input for the n, which is the number of the boxes. Then I have taken the input for the number of chocolates in each and every box. Then we need to just add to our answer a of I minus the minimum number of chocolates present in the entire array, which we can get by indirection of min element a dot begin comma n dot add a of n. So this is our solution. So now let us move to problem C. The statement of the problem is as follows. You are given n words of equal length m, okay, consisting of lowercase Latin alphabets. The ith word is denoted by si. In one move, you can choose any position in any single word. That means we can choose any letter of any word and change the letter at that position to the previous or next letter in the alphabetical order. For example, okay, so we can change E to D or F. A can be changed only to B and Z can be changed only to Y. The difference between two words is the minimum number of moves required to make them equal. For example, the difference between best and cost is 1. 1 because we need only one operation to change B to C, plus 10 because E can be changed to O by 10 operation, plus 0 plus 0, which is 11. Find the minimum difference of Si and Sj. In other words, find the minimum difference or all possible pairs of the n words. Okay, the first line contains two integers n and m, the number of strings and their length. Then we have n lines which contain the word. Okay, so let us see the approach of this problem. Okay, so in this problem, I can replace any character by its previous alphabetical character or its next alphabetical character. So this means that if I want to change one character, suppose I want to change ch1 to another character ch2, then it will require me abs of ch1 minus ch2 operations. For example, if my ch1 is equal to a and my ch2 is equal to d, then the number of operations required to change a to d will be abs of a minus d, which is 3. Why? Because in one operation I can change a to b, then b to c, then c to d. So a total of 3 operations will be required. Now if I consider any two strings s and t, then to change s to t, for example, if I want to change all the entire string s to t, then it will require me abs of s of 0 minus t of 0, because I will change the first character, and to change each character I require abs of ch1 minus ch2 that we have seen above, plus abs of s1 minus t1 plus abs of sn minus tn operations. A total of this much operation will be required. Now if we see in the problem, the constraints are so small that we can calculate this value for every pair of strings I and j, and we will select that pair of the strings which gives us the minimum value. So we can see the code. Okay, so first I have taken the input for the test number of test cases. In the test cases I have taken for the n and m. N is the number of the words and m is the length of each and every word. Then I have taken the input of the n words. First I have initialized my answer to int max. Then as I have said, the constraints are so small, then we can apply an approach of O of n square. That means we can select every pair of words. So for each I from 0 to n and j from I plus 1 to n, we will check how many operations are required to change ith word to the jth word. So it will be abs of s of I comma k minus s of j comma k, and we will add it to the variable temp, and for each pair ij we will check which is the minimum. Answer is equal to minimum of answer comma temp, and we will output the value of answer. So this is our solution to the problem C. Now let us discuss problem D. The statement of the problem is as follows. Timur's grandfather gifted him a chessboard to practice his chess skills. Okay, this chessboard has n rows and m columns, with each cell having a non-negative integer written on it. Okay, Timur's challenge is to place a bishop on the board such that the sum of all cells attacked by the bishop is maximal. The bishop attacks in all cells diagonally, and there is no limit to the distance which the bishop can attack. Note that the cell on which the bishop is placed is also considered attacked. So we need to find the maximum sum that we can get. The first line of each essay contains the initials n and m, the dimensions of our chessboard, and then we have n into m integers which show the value which is written on the I comma j cell of our chessboard. Okay, so we need to find the maximal sum of the cells which we can get by having our bishop placed at a position which the bishop can attack. Okay, so the first thing that we need to understand is that how our bishop can move. Suppose our bishop is currently in cell with coordinates x and y. So suppose our bishop is here in the cell marked with b, is x coordinate is x and the y coordinate is y. So our bishop can move diagonally, that is it can move in this particular direction, in this direction, in this direction, and in this direction, and there is no limit to the distance to which it can move, but it can move diagonally. Now as you understood how our bishop can move, now we need to understand if our bishop is placed in a particular cell, then what is the sum of the cells that are under attack. So suppose our bishop is in cell x comma y, as we suppose. So the first cell under attack is x comma y itself, because the cell in which the bishop is placed is also considered to be attacked. So the first cell under attack is this cell itself. So we need to add value of that cell to our answer. Now we can move diagonally in 4 directions: this direction, this direction, this direction, this direction, and we will calculate the sum for all the 4 directions one by one. To calculate the sum in this direction, in this particular direction, we can go on reducing the value of x and y by 1 till they are greater than 0, and add the value of that cell to our answer. For example, our current cell is x comma y, so our next cell will be this one, x minus 1 comma y minus 1. The row is reduced by 1 and the column is also reduced by 1, and then the next cell will be x minus 2 comma y minus 2, and so on. We will keep on reducing the value of x till x is greater than 0 and y is greater than 0, and so all our cells in this particular diagonal will be covered. Now to calculate the values of this diagonal, as we can see, y will increase because the column we are now going is to the right of our bishop cell, so y will increase and the value of x will decrease. So to calculate the values of these cells, we will keep on reducing the values of x till x is greater than 0 and increasing the values of y till the value y is less than m, and keep adding the values of the cell to our answer. Similarly, to calculate the sum of the cells in this particular direction, we will increase both x and y because our row is also increasing and column is also increasing till x is less than n and y is less than m. And for calculating in this particular direction, the value of x is will increase because the row is increasing, and the value of y will decrease till y is greater than 0 and x is greater than n. Now we have seen that if our bishop is placed in a particular cell, how to calculate the sum of cells that are under attack. But how we will find the maximum sum? So if we look closely at the constants are so small that we can check this condition for every cell in the chessboard. Okay, so if you see the constants are 200 and 200. So we can apply an approach of more than n square to calculate our answer. So let us see the code for this particular problem. Okay, so I have first taken the input for n and m, which is a dimensions of a chessboard, and then I have stored the values in a two-dimensional array A, the values of our cells of our chessboard, and then the variable answer will denote our final answer. So we can place the our bishop in any particular cell. So for all I from 1 to n and all j from 1 to m, we will test if the temp is initialized to 0. Then we will add the value of that particular cell to which our bishop is initially placed, which is I comma j. So temp is equal to temp plus a of I plus I comma j. Then first we will go in this particular direction. So we will reduce both x and y. So we have done that in our code. We have reduced both x and y till x is greater than 0, y is greater than 0. Temp is equal to temp plus a of x comma y, x minus minus y minus minus. Now once we have reached this particular endpoint, now we will go in another direction. So x will decrease and y will increase. So we have done that in our code. While x is greater than 0 and y is less than or equal to x minus minus and y plus plus. Similarly, these are the other two directions of the diagonal that we need to check. And finally, we will check whether our calculated value of the temp is greater than answer. So answer is equal to maximum of answer comma temp. And finally, we will output the value of our answer. Okay, so I hope this was clear to you. This was our solution for the problem D. So now let us discuss problem E. The statement of the problem E is as follows. Timur has n candies. The ith candy has a quantity of sugar equal to AI. Okay. So by eating the ith candy, Timur consumes a quantity of sugar equal to AI. Timur will ask you Q queries regarding his candies. For the J query, you have to answer what is the minimum number of candies he needs to eat in order to reach a quantity of sugar greater than or equal to xg, or print -1 if it is not possible to obtain such a quantity. Okay, so we will be given an array where each element of the array will represent a sugar level of the ith candy, and then we will have j queries, and each query we will be given an integer x, and we need to output the minimum number of candies that we need to eat to have a sugar level greater than or equal to that particular value x of j. And if it is impossible, we need to print -1. In other words, you should print the minimum possible k such that after eating k candies, Timur consumes a quantity of sugar at least xj, or say that no possible k exists. Note that he can't eat the same candy twice and queries are independent of each other. Okay. The first line contains 2 integers n and q. This is the number of candies and the queries that we need to answer. The second line contains n integers, which are the quantity of sugar in each of the candies. Then we have the queries. Each of the query will have a single integer x, the quantity Timur wants to reach for the given query. Okay, the output for each test case we have output q lines, one line for each query. For the jth line, output the number of candies Timur needs to eat in order to reach a quantity of sugar greater than or equal to xj, or print -1 if it is not possible. Okay, so if you come to the approach of this problem, So I hope all of you understood the problem statement. So we will be given q queries, and in each query we will be given an integer. We need to output the minimum number of candies to reach that particular sugar level. If we want to minimize the number of candies for a particular given sugar level, a basic greedy thought that will come to our mind is to pick first the candies with greater sugar content in them. Okay, so we can sort the array in decreasing order of the sugar levels of the candies. Once again, how this idea came to our mind that we need to sort the array in decreasing order of sugar level? This is because we can greedily first select the candies with more sugar to minimize our answer. Okay, but as we can see, the queries are of the order of 10 raised to power 5. So we can at most give log of n time to answer each query. To do that, we can create a prefix sum array which will store the sum of the sugar contents of the candies till that index. What we can do is first we can sort the candies in the decreasing order of the sugar content, and then we will create a prefix sum which will store the sugar contents of the candies till that index. Now, since all the values in this prefix sum array are increasing, it is monotonic. So we can use binary search to find the lower bound of the sugar level given in each of the query, because it takes only log n time. So overall, the queries will be answered in OOQ into log n, which is acceptable. So let us see the code for this particular problem, and we will see the finer details. So if we see the code, first I have taken the input for n and q, the number of the candies in the queries. Then I have stored the sugar level in the array A. As we have discussed, first we will sort the array in the decreasing order. So first we will sort and then reverse it. Then we will create a prefix sum array which will store the sugar level of the candies till that particular index. So we have created the array sum of n, and sum of 0 will be initialized to the first candy sugar level, which is a of 0, and then for every I, sum of I will be the sum till the previous candy sum of I minus 1 plus the current candy a of I. Then for every query, while q minus minus, we will input the sugar level that we want, LLX, and we will input it C in X. Then we will check if the sugar level is greater than the sum of all the sugar levels of all the candies, then we cannot do anything. So we will print minus 1. Otherwise, we will apply the binary search to search for the given value of the sugar level X in our array. So the the lower index will be 0 and the upper index will be n minus 1, and we will search till L is less than or equal to R if sum of M, which is the sugar level of our middle element, is less than the required level, then we will increase the value of L to M plus 1. Else, if it is greater, then we will decrease the value of R to M minus 1. And finally, we will output M plus 1 if our sugar level is exactly matched. Otherwise, we will output L plus 1. So, in this question, we use two concepts. One is of the prefix sum and another one is of the binary search. Okay, so if we see what were the important learnings from this contest, then first, we should always first check the size of constraints, because if constraints are not so large, then we can always apply brute force, because in this particular contest a total of 4 problems could be solved very easily if we can see the size of the constraints are very small. Second, prefix sum to store the values till a particular index, which helps in answering the queries faster. As we saw in problem E, we could answer the queries very fast since we use the concept of prefix sum. Third, binary search. If our function is monotonic or our array is sorted, then we can always apply binary search to find a value in O of log n time instead of applying the normal linear search. which takes a time of O of n. So these were the important learnings from the contest. Thanks.